Good afternoon. Am I audible?
Yes, ma'am.
Yes.
Okay. So, we were trying to map the company database to the relational database. I have already given the lecture video for this, and we have already started in the classroom also this mapping. So, because you people didn't respond, I think we have to repeat, means let us repeat all the things again, once again, using the ER model that I had given you, means I had just sent you in the WhatsApp. I had, did you see the ER model that I shared in the WhatsApp group?
Yes, ma'am.
Yes, ma'am.
All of you open that ER model. And we are going to do this mapping together, because I know you people already have some idea about this, and let us do the mapping together. So the first thing, you just open that particular ER model for company database, and then let us start the mapping. Okay, and in the from the next class onwards, means we have to complete this today itself, and then from the next class we'll start SQL. Okay. Okay, then so the first step is to map regular or strong entity type, isn't it? So tell me the strong entity types that we have in the company database. Anyone?
Ma'am,
Tell me
employee,
the entity types. Yeah,
employee,
employee.
department,
Yeah, and then
project,
department, and then first. Okay. So these are the strong entity types. We have 3 strong entity types, isn't it? So according to the things that it is saying, we are going to map, means whatever strong entity type we have, we are going to map it to a relation, isn't it? So the relation means if we are going to map to a relation, that means we have to show, means we have to represent it as a relational schema, isn't it? So let us just try to represent it in a relational schema. Okay. So suppose this is the relational schema for employee. What things we have to include here? According to this step, include all simple attributes and simple components of composite attributes of E as attributes of R. Then tell me the attributes. Whatever attributes we are going to add here, tell me.
Mem F name, M name,
F
and
name,
M name,
L name,
address, a birth DOB.
M name. There is also M name, isn't it?
Yes, yes,
M
yes.
name, M name, L name, and other
DOB,
things.
DOB,
Address.
DOB, DOB address,
Wait. Okay. Address,
DOB,
date of birth,
gender,
and then
gender, salary,
okay, gender,
salary,
salary.
and ID mem as a personal ID
Is
employee
there
ID.
any more?
EID,
attributes, we have F
employee,
name, middle name, S name, salary,
ma'am,
and
employee
then
ID.
the robot, address, genders, and then we have SSN, isn't it?
Yes,
Yes. Yes. Okay. So these are the simple attributes and the simple components of composite attributes. We have to add it as an attribute for the relationals, for the relation that we just created. Okay. So we have to follow these steps. Means we have to do the same thing for department also. Okay. So this is for employees. Employee doesn't have any other things. Oh, wait. We have to, means let us do this other things here. Choose one of the key attribute as the primary key. So from here, in this employee, this one entity type, we have only one key, isn't it? There is only one key attribute, and that is SSN. So
yes,
if
ma'am.
there is only one, then we have to select that as a primary. So this SSN is going to be the
Primary.
primary key here in this relation employee. Okay. And other things are, if the chosen key attribute, no, it is not a composite attribute. So we do not care about this particular, this one point. Let us go for the department. Let us do the same thing for department. Let us say this is the relational schema for department. Tell me the attributes that we are going to add here.
The name of the department,
Name of the department,
serial number of the department as, or we can number of,
number, department number, isn't it?
yes, location also can be
No, ma'am, not location. Multi-value
Location,
can.
we can't add location here.
multi-valued.
Okay.
Um,
Why? Because location is a multi-valued attribute.
yes, ma'am.
So we do not means here only simple attributes and simple components of composite attributes. We are going to add those things. So multi-valued just means just leave the multi-value attribute. So we have only these two attributes. From here, we are going to choose the key attribute. So this both of them, the name and the number, both of them are key attributes, isn't it?
Yes, ma'am.
So
Both of
from
them
this
implemented.
two, you have to choose only one. Choose one of the key attribute as the primary key. So let us choose this D number as the primary key. Okay. I have just left this space like this because, yeah, like this because I can rub it, but just okay. Let me do one thing. Okay. So this is your department, and let us see how the relational schema of project looks like. So tell me the attributes that we are going to add here.
There will
For
be
project,
name, the project
it will
name,
be project name,
and there's project number,
project number,
and then the location.
and the location. So these are the attributes. And again, from here, we are going to choose the key attribute. So let us choose D number because D name and project name and project number, both of them are key attributes. So let us choose from this two, let us choose the P number as the key attribute. Okay, so this means we have done this step number 1. Now let us see step number 2. Step number 2, mapping of weak entity type. Tell me which one is is there any weak entity type in the company database, company ER model?
Yes, ma'am, dependent.
Yeah, dependent is the weak entity type here in your company database. Okay, So for dependent, what we are going to do is we are going to map the weak entity type to a relation R. Same thing that we have done in the for the strong entity type. So I will just draw the dependent somewhere here. Okay. For dependent, again, we will have a relation for dependent also. And what we are going to do here is include all the simple attributes, simple components of composite attributes of W as the attributes of R. So tell me the attributes that we are going to add here in the dependent relation.
Ma'am, name, sex, birth date, relationship, and on and foreign key. That is SSN.
Name, sex, birth date, and relation. Just for now, these are the things we are going to add here, isn't it? Let us see the next step. We have done this particular point. Include all the simple attributes, simple components of composite attributes of W as the attributes of R. So whatever attribute, whatever simple attributes we have in the dependent entity type, weak entity type, we have to add it here. Okay. The next point, let us read the next point. So from here, by using this point, we are going to add the other attributes. Let us see. Include the primary key attribute of the relation which correspond to the owner entity type as the foreign key. So we are going to add a foreign key here. And what this foreign key, which attribute it is going to refer is the primary key of the relation which is corresponding to the owner entity type. So what is the owner entity type in the ER model for
Employee.
dependent employee, isn't it? So employee, we already have the relation here. So for this employee, what was the primary key? Primary key is SSN. Okay, so we have to add this SSN here as a foreign key. According to point number 2, we are going to, let us name it ESSN. Instead of SSN, we can give the name as SSN also. Okay, do as you want. Okay, you can also give social security number, the long this one, the whole thing about SSN. Okay, so you can, the name of the attributes, it depends on you also, on the designer. So you can choose, you can name it as you want. But what it is going to do is the things, what it mean is it is going to be a foreign key referring to the primary key of the relation which is corresponding to the owner entity type. So it is going to be a foreign key referring to this SSN. Okay, so this is a foreign key. ESSN is a foreign key. Okay, how these foreign keys are represented in a relational model, I will show you later on. But for now, just remember that this is a foreign key. ESSN is a foreign key. Let us read the next point. The primary key of R will be the combination of the foreign key and the partial key of the weak entity type. What is the partial key for the dependent entity type?
Name.
Name is the partial key. So the combination of the foreign key means the set. Is going to be, the primary key is going to be a set here where we have two attributes. One is the foreign key and another one is the partial key. So it is going to be a set of this containing, the set will have this name and ESSN as its and this one elements. Okay. So the combination of name and ESSN is going to be the primary key of dependent. Okay, so we have done everything for this weak entity type. Whatever point we have, we already followed it. Let us go to the next step. Mapping of binary 1:1 relationship type. So binary 1:1 relationship type, I already mentioned that there is 3 approaches. The first one is foreign key approach, where what we are going to do is one of the entity types should be having a total participation and another one should be having partial participation. Okay, then what we are going to do is the relation which is corresponding to the entity type participating as a total participation, there we are going to add a foreign key. Okay, we are going to add a foreign key, and that is going to be referring to the primary key of the other relation. Okay, so this is the first approach. Means the relation which is having total participation, we are going to add a foreign key, and this foreign key is referring to the primary key of the other remaining relation. Okay, so that is foreign key approach. Other than that, we are going to include all the simple attributes or simple components of composite attributes of the relation REL. Okay, means REL relationship type can also have this one attributes, isn't it? If it has any attribute, then we have to add that attribute. Say for example, this T is having total participation, and this S is having partial participation. This is for the approach number 1, okay, foreign key approach. So if it is S is having partial participation and T is having total participation, then in this relation T, we are going to add a foreign key referring to the primary key of S. Okay, other than that, whatever attribute this relationship type has, we are going to add that also in T as an attribute. Okay, so that is the foreign key approach. And I will tell you the next one, merge this one, if both of them has total participation, then then we can also use this merge relation approach. Okay, so this is a restriction given for this particular approach. Both of them should be total participation, having total participation as a participation constraint, and again it should be 1:1 binary relationship type. Okay, so if we are going to use merge relation approach, then what we are going to do is we will merge the relation S and T into a single relation. Okay, into a single relation, and the combination of the primary key of S and the primary key of T will become the overall primary key of the resultant relation. Okay, and that is merge relation approach. Let me check. Yeah. So that is for merge relation approach. And one more thing, again, I will tell you, both of them should be having total participation, and it should be binary 1:1 relationship type. That means it has so many restrictions. And another thing is, this is a very risky approach. Okay, this is a very risky approach. If when we design the ER model, if the ER model has some error in it, means if there is something wrong in the ER model, if it is not a correct ER model because of some requirement requirement, and if we done anything wrong in the requirement analysis, then what happen is it will be the ER model is going to be a wrong model. Okay, if anything is wrong there, and if we use merge relation approach, then after actually using when the database is actually created, we are going to face some inconsistency later on. After entering many data in the database, there means later on, after 1 or 2 years using the database, there might be some inconsistency might arise. Okay, so that is why I told you that just know what is this merge relation approach, but do not use this one. Okay, I do not recommend this particular approach, merge the relation approach. Okay, the next one is cross-reference or relationship relation approach. This can be used for any forms of this one relationship type, means whether it is whether it is a binary relationship type or whether it is means whether it is having a total participation or total partial participation or partial participation, whatever, it doesn't have any restriction. You can use this cross reference or relationship relation approach. Okay, what we are going to do here is for this REL, without adding anything in S and T, we can directly create a relation R for this REL, a separate relation from S and T. Okay, in this for this REL. So that is why the name is relationship relation approach. For the relationship, we are creating a relation. Okay, so in that relation, what we are going to add is the primary key of S and the primary key of T. There will be, for sure, there is going to be two attributes. One is the primary key of S and another one is the primary key of T. So both of them is going to be foreign key in that relation. And again, combination of those two is going to be the primary key of that relation. Okay, other than that, if REL has any, if it has any simple attributes, then we are going to add it there here in this relation. Okay, now let us see what we can do for the company database. Is there any binary 1:1 relationship type in the company database?
Ma'am, managers.
1:1. Yeah, managers, and it is between employee and department, isn't it?
Yes, ma'am.
Employee and department, and one of them is having total participation and one of them is having partial participation. That means we can either use foreign key approach or we can use cross reference or relationship relation approach. Okay, we can't use merge relation approach here. Okay, why we can't use merge relation approach is when you enter data, you will be able to understand this. Just tell me why we can't use merge relation approach for other types of relationship type. Okay, just you do it as a homework, and this is when you entered data, you will be able to understand it. So just tell me in the next class, tell me why we can't use merge relation approach for this particular relationship type manages. Okay, so let us see, if we use foreign key approach, then what will happen? That means if we use foreign key approach in the department relation, which is having total participation, here in this department relation, what we are going to add? A foreign key, isn't it? We are going to add a foreign key. Isn't it? According to the foreign key approach. Foreign key approach says that in the relation which is having total participation, that is T, we are going to add a foreign key, which is referring to the primary key of S. Here, what is T? T, which is having partial participation. Sorry, total participation.
Ma'am, department.
Yeah, department. T is going to be department, and S will be
Employee.
employee, isn't it? So in the department relation, according to the foreign key approach, in the department relation, we are going to add a foreign key referring to the primary key of employee. That means the primary key is SSN, isn't it? So we will have a foreign key here. I will name it ESSN again. Okay, and this is a foreign key referring to the primary key of employee. Okay, do you get it now? This is the foreign key approach. And whatever entity, whatever attribute the relationship type has, we have to add here again that particular thing, and that is start date. We have an attribute for managers, isn't it? For the Menezes relationship type, just see the ER model of the company database. The Menezes relationship type has a attribute start date. Okay. Is there something wrong here? No department. Okay. Wait. Yeah, we have to add this start date. We have to add this start date. Okay. Do you have any doubt? Any doubt here? Because according to foreign key approach, I told you that in the relation which is having total participation, we are going to add the foreign key referring to the primary key of the other relation and also the attributes of REL. Whatever attributes REL has, simple attributes, those things we are going to add here in T. Do you get it now? And do you have any doubt?
No, ma'am.
If you have any doubt here, then you just ask me before further going to the before going to the further steps. Okay, so this is using foreign key approach. If we use cross-reference or relationship relation approach, then for the Menezes relationship type, we are going to do what we are. I just draw it somewhere here because we are not going to use that approach. If we use that approach, then we'll be having a Menezes relation where it will include three attributes. It will have three attributes. One is SSN, another one is the number. We are going to add the primary keys of the two relation S and T. Okay, so this two will be, we have to add it, and if there is any attribute for Menezes, then we have to add that also. So we have the start date, isn't it? So we'll add start date, and the combination of SSN and D number will become the primary key. SSN is a foreign key, SSN separately is a foreign key, D number individually it is also a foreign key, but together they are the primary key. They will become the primary key together. Primary key will be a set of attributes containing two attributes. One will be SSN and another one will be D number. Okay, so this is for using what approach? The relationship relation approach. Okay, that means you can either use foreign key approach or relationship relation approach. This is also correct, and whatever we have done here, it is also correct. So whatever approach you are, means if you are comfortable with relationship relation approach, then you can use it. If you are comfortable with foreign key approach, then you can use foreign key approach. Okay, so for this particular example, for me, while explaining this particular mapping, I'll use foreign key approach. That is why I will just remove it. Means I am not going to use this. relationship relation approach here. Okay, so let me remove this one. You get it? You get it now? You need to respond.
Yes, ma'am.
Both the approaches. Okay. Okay, then let us go to the next step. This is for binary 1:1 mapping. There is no more 1:1 relationship type, is it? Is it? Yeah, there is no more 1:1 relationship type in the company database. The next step is mapping of binary 1:n relationship type. 1:n relationship type. So if we are going to use if there is any 1:n relationship type, then what happen is we can use two approaches. The first one is foreign key approach, the another one is relationship relation approach. Both approaches we already see how we are going to this one, how we are going to the mapping according to these two approaches. For the foreign key approach, what we are going to do is, if S is the relation which is having the N and T, in the T side we are having 1, then let us see, include as foreign key in S the primary key of T. Okay, if we are using foreign key approach, then include the primary key of T as a foreign key in S. So there will be a foreign key in S. Okay, referring to the primary key of T. After that, include any simple attributes or simple components of composite attributes of REL as attributes of S. Okay, other than the foreign key, we have to add the simple attributes of REL also in S. Okay, so this is for foreign key approach. If we are using relationship relation approach again, then what we can do is, we are going to create a we are going to map this REL to a to a separate relation R. In that relation, we will add the primary key of S and the primary key of T. Combination of those two will become the foreign this one. Combination of those two will become the primary key of the resultant relation. The relation that we just created. Okay, and if there is any simple attributes of REL, then we will put it there here also. Okay, so this we already know. Let us see what we can do for the company database. Tell me the 1:n relationship type in company database.
Works for.
Works for, that is between employee and department. Okay, let us do mapping for this one first. So works for. Works for. Uh, Works for, let us see if I can just put it here. Okay, wait. Works for, let us see first the whatever we can do, whether we are going to use foreign key approach or this one. Cross relationship relation approach for this one. So works for employee is the relation which is in the end side, and department is the relation which is in the one side, isn't it? So that means if we use foreign key approach, then we are going to include the primary key of T as the foreign key in S. Okay, so what will be the T here for works
Department.
for? T will be department and S is going to be the employee, isn't it? So in the in the employee relation, okay, in the employee relation, that is this S. Okay, in the employee relation, we are going to add a foreign key which is referring to the primary key of T. Okay, let us do that. So there will be we are going to add a foreign key here in the employee relation, and it is going to be referring to the primary key of department. So what is the primary key of department? D number, isn't it? So let me name it as D num. Okay, and see, this is a foreign key referring to the primary key of D number. Okay, other than that, what we are going to do is, if there is any simple attributes for works for, there is no simple attributes, so we'll skip this particular point. So this is how we can use foreign key approach for 1:n relationship type. If we use relationship relation approach, this is a very simple approach. If we use this one, this is very simple. You just create a relation works for, in that works for, add this one, the primary key of S and the primary key of T as a foreign key, and both of them in combination of those two will become the primary key. Okay, I'm not going to show that. We already see this in the means in the manager's relationship type. So this is how we are going to do mapping for 1:n relationship type. Is there any more 1:n? Yeah, there is one more 1:n relationship type. No, there's two more 1:n relationship type. One is, tell me,
Controls and dependent of.
dependent of, we already done, means this is a identifying relationship type. So for identifying relationship type, we already done representing it when we map the weak entity type dependent. Okay, so you
Uh,
do not need to consider this particular relationship type. Okay,
Ma'am, then controls like a department can have multiple projects.
Ma'am, supervision.
control and supervision. Okay, controls and supervision is the other two remaining 1:n relationship type. So for controls, again, I'll use the foreign key approach because I means I prefer this particular one, so that is why I'm using foreign key approach again and again. Okay, so for controls, what we are going to do is, in the project relation, we are going to add the primary key of department. So in the project, I'm going to add the primary key of department. Okay, and it is the foreign key referring to the primary key of department. Okay, same thing for supervision also. For supervision, one site is also employee and site is also employee. So in the end site, employee, whatever we are going to add is, we will add another foreign key here, and this is going to be SSN, because SSN is the primary key of the other site. Means both of them means it is this one, recursive relationship type. That means the other side we have employee, and then means S is also employee here, S is also employee, T is also employee. Okay, so if we consider this T, that is employee, then we are going to add the primary key of S here in T, isn't it? So like that means both of them are employees, so we will just add the SSN here again. E, let us say super SSN. Super SSN. Okay, so this is a foreign key referring to this SSN. Okay, this super key is referring to the SSN. Okay, so this is mapping of 1:n relationship type. If supervision has any more attributes, then we have to add it here. So there is no simple attribute for supervision, so we do not need to do that thing. Even for controls also, there is no this one, any simple attributes for controls, so we do not need to add it to this project. We have done representing 1:n relationships. So we have done this. Let us go to the next step. mapping of binary M is to N relationship. So for this, we have to use relationship relation approach. Okay, so we know what is relationship relation approach. Let us go to the example directly to the example. So there is one M is to N relationship type in the company database. And what is it? Tell me.
Works for.
Works on.
Works on, sorry, ma'am.
Project to
Yeah,
employee.
works on. So works on is between employee and project, isn't it? So for works on, we have to create a separate relation because it is an is to N relationship type. Okay, so we'll be creating a separate relation for this. And here in works on, we'll be having the primary key of S and the primary key of T. Okay, so here S is, you can, means employee, and it is between employee and project. So primary key of employee is SSN, employee SSN, and the primary key of project is P number. Okay, and is there any simple attributes for works on?
It's
Yes,
hours.
isn't it? So we'll be having 3 attributes here. And ESSN is the foreign key referring to the employee relation, and P number is the foreign key referring to the project relation. Combination of these 2 is going to be the primary key. So this is relationship relation approach. If we are going to use relationship relation approach for the other types of relationship, then you have to do like this. Okay, I'll tell you one thing here. Whether it is an M is to N relationship type, or 1 is to N relationship type, or 1 is to 1 binary relationship type, all of them can use relationship relation approach. You can check it. All of them can use relationship relation approach. Okay, so I'll just give you one tip. If you are not able to understand the foreign key approach and the merge relation approach, then just try to understand very clearly about the relationship relation approach, because you can use this for any type of relationship type. Okay, then you are not going to make any mistake if you use this relationship relation approach. Do you get it?
Yes, ma'am.
Okay. And this is for an array relationship type, means we were looking for binary relationship type. All of them were binary relationship type. And in our company database, there is no an array relationship type. Okay. But if there is any ER diagram, if there is any design, ER model of a database which contain an array relationship type, that means the participating entity type is more than 2. Okay, if the participating entity is more than 2, well, it can be a 3 or a 4. Okay, then for those, again, you have to use relationship relation approach. So for example, if there is a relation REL and it is between 3 relation S, let us say S1, S2, and S3. Okay, there is a relationship REL in your entity relationship model, which is where there is 3 participating entity types, S1, S2, and S3. Then we are going, by using relationship relation approach, for this REL, we have to create a relation R. We have to create a relation R where we are going to have 1, means it can be combination of attributes also, isn't it? Because primary key can be made up of combination of attributes. So the primary key of S1, we have to put it here as a foreign key. The primary key of S2, we have to put it here as a foreign key. The primary key of S3, we have to put it here as a foreign key. Okay. 1 is referring to S1, 1 is referring to S2, and the other remaining is referring to S3. Okay. And the combination of those 3 primary keys will become the primary key of R. So that is relationship relation approach, isn't it? We already know what is this relationship relation approach. So any form of an array relationship type, whether the degree is 2, 3, 4, 5, whatever, you have to use relationship relation approach. Okay, that is why I told you, if you are not able to understand the other two approaches, you just need to understand what is relationship relation approach, because for any type of relationship we can use relationship approach. Okay, so that is step number 6. Let us see step number 7, mapping of multi-valued attributes. So there is still some multi-valued attributes, means we do not, there is no, so far we do not see any representation for the multi-valued attribute, isn't it? So in step number 7, the last step, what we are going to do is, for the multi-valued attribute A, we have to create a relation R, a separate relation for the multi-valued attribute. Okay, so we have to create a separate relation R, include the attribute itself, okay, the multi-valued attribute itself as an attribute, include as foreign key the primary key of the relation corresponding to the entity type or relationship type that has A as an attribute in the entity relationship model. Okay, so this is just some simple things. Include components if it is a complex attributes. If it is a complex attribute, means it is composite as well as multi-valued, isn't it? If it is complex, then it is going to have components. So include those things also. Okay. So in the company database, there is a single multi-valued attribute, and that is location, isn't it? Location for the department entity type. Do you get it? Do you get whatever I'm saying?
Yes, ma'am.
So location is the only multi-valued attribute we have in our company database. And for this location, we have to create a separate relation, and the attributes will be the location itself. Location itself, and another attribute is going to be the foreign key, referring to the primary key of the corresponding entity type or relationship type that has A as an attribute. Okay, so corresponding, this is location is for the department entity type. So for department, the primary key is department number, dnum. Okay, so dnum is going to be the foreign key referring to d number. And what will be the key attribute here? The key attribute is not mentioned, but I will tell you the key attribute is going to be the combination of location and d number. Okay, so it is going to be a set containing location, okay, department number, both of them. I just know this one, department, the primary key is the combination of and d number. Okay, so we have done representing the company database. This is the last step. We have done representing the company database. Now the remaining thing we need to do is the references. Whatever references we have, whatever references are there, we have to represent it by using arrowheads. Okay, so here this D number is okay, D number is, this is going to be a messy thing, but still I will draw it here, how we are going to represent it. So dnum, this dnum is a foreign key referring to this D number, isn't it? So you have to draw a line from the foreign key to the here this primary key which it is referring, and the arrowhead should be given here in the primary key. Okay, same thing for supervision also. Super SSN, this one is referring here to this SSN, like this. Okay, this ESSN is referring to this SSN. Okay, so you have to represent the references also like this by using the arrowheads. D number is referring here in this D number, and then again here is also a D number. So the overall representation, I'll just show it here. Can you see this one? Let me open a new file. This is not very clear, but still you can see here the foreign key SSN, this one is referring to SSN. So there is a line from the foreign keys to the primary keys in which they are referring, to which they are referring. Okay. Is that clear? Any doubt in this mapping? Can you hear me?
Yes,
Yes,
ma'am.
ma'am.
I have already shared the class notes also for starting from the first class till here. Okay, you can refer those class notes also. So from the next class, we will start SQL. And for this one, designing ER model and mapping it to the relational model, I will give this one an assignment for it. Okay, I'll give the assignment today or tomorrow. So now let me take your attendance. Please 14. A visit
Present, ma'am.
Akash,
Present, ma'am.
Atul,
Present, ma'am.
AR Sorinjui,